Now here's a very metrological looking item that I picked up at a garage sale the other day for 20 bucks, pretty good. Victorian Meter Laboratory, Melbourne, Australia. Sounds like a government standards laboratory here in Melbourne, but as far as I can tell it no longer exists, at least not under that name. So, nice wooden box. Somehow its lid has been rusted, the hinges on the lid have been rusted in the half open position, so I think the first thing to do with this unit will be to remove those hinges. Some sort of a resistance bridge, galvanometer in there by the look of it, and it's got a little mirror behind there and it seems to move freely, so that's probably a good sign. Battery and galv, there's some button here for that, so maybe it contains a battery. And we've got some sort of a cover down here. Don't know what that's for. We'll lift that too. And we've got instructions in the lid. And a leather handle at the top. So, yes, first thing to do will be to take the hinge off, have a look under here. It's got foots and there's one foot missing. So it looks like it's meant to stand upwards. I thought it might have to sit like that, but okay, it looks like it's meant to stand vertically. So those feet will need replacing as well. Let's get into it. And he does come with some instructions. High Street Armadale. Oh, that's full of antique stores these days. Also make something, meters, galvanometers, something else, etc. 1959. Yeah. And having looked a bit closer, I can see that these 2 feet here seem to indicate that it's meant to be stored that way up, but perhaps to be operated it's meant to be laying on its back. That seems to make more sense to me. And also looking at this sheet here, also makes attenuators, meters, galvanometers, spot, pyrometers, etc. That's what that says. Now this is a type WB4 as supplied to the PMG, which was Postmaster General's department, a government department back in the old days that looked after postage and communications. It was then split off, the communications part was split off to become Telecom and later privatised as Telstra these days, along with its shit share price. And this appears to be a battery compartment, so taking that off should 4 small round torch cells. Now, if they're still in there after all these years, there's going to be some pretty awful corrosion, I imagine. So yeah, I'll take the hinges off, have a look at that, take the top off and see what's inside. Well, the good news is that there doesn't seem to be any batteries in there to rust away, corrode away and destroy the insides. This hinge I couldn't get the screws off, but I'll work a bit harder at that. Maybe these will respond to WD-40 or some other rust removal stuff. If not, I'll have to replace them. And it's got a user manual, user guide, which seems to be in pretty good condition. And maybe that's our circuit up there. Let's have a look inside and see if it matches. But you know, I've got to do a bit of reading up on Varley and Murray and Wheatstone bridges. But yeah, range. Now, given that it was supplied to the PMG, which is not a high metrology organisation, I wouldn't think. Well, maybe it went into their semi-standards laboratories. It might be quite a good precision thing. I don't know. It may not be, but maybe they just made things well enough in those days. Alright, time to lift that lid out. So 6 threaded, to be 1/8 inch screws should allow us to remove this from its Queensland maple box. Comes up pretty easily. Gotta get that battery box up. Okay, it's a bit dodgy. Again, a bunch of precision resistors, this time going up into the thousands of ohms, and galvanometer in there. Probably won't open here unless I need to trace out the circuit. Battery compartment looks like it was meant to be glued down, that's long fallen away. 4 D cells by the look of it. Looks pretty nice. Be interesting to put those resistances on a 6.5 digit meter and see what it says with 4 wire mode. So it appears this is the circuit for that, though it's a little bit confusing. In particular, I find these switch symbols a bit ambiguous. Maybe I'm just being thick, but it's not clear to me what is connected to what in which position. Anyhow, this resistance here is these 4 resistors here, which are in series. The multiplier is this switch, galvanometer. This switch is for turning on the battery and connecting the galvanometer into the circuit. This switch protects the galvanometer. It either shorts it so that no current can run through it, or passes it through this resistor, or it's open. So I imagine you'd have it in this shunted position with that resistor across the galvanometer until you've got close to the 0 point, then you'd switch to open for the final adjustment. These resistors here are for when you apply an external voltage, which can be up to 135 volts for measuring very large resistances. Now the Varley and Murray tests, they're to do with finding a short circuit in a phone line, I guess, a short to ground, or one of them's for a short to ground, one of them's for some other sort of short. Anyway, I'm not interested in that. If you are, you can look it up. There's plenty of information about that on the web, but I'm predominantly interested in the Wheatstone Bridge mode. So that's in that position there. I'll show you the simplified diagram of that in a minute, but first let's just measure these resistors here, which is available across terminals 1 and 2, which are these guys. Okay, I'll put it back in the box. Few specs: accuracy 0.1% of true 0.1% of true resistance, except for values below 0.1 of an ohm. Manganese wire wound resistance. Beryllium copper switches. Decade dials. That's 4 dials are continuously variable, have a total resistance of 0 to 11,110 ohms in 1 ohm steps. A separate terminal permits usage, so as an accurate 4 dial decade resistance test box. That's what we're going to do in a minute. You can just use the bottom 2 terminals and those resistors just as a resistance box. Now, as the switching is in the battery circuit and not in the bridge circuit, All ratios are precise and unaffected by switch resistance. Not 100% sure that that's true, but we'll look at that when we have a look at the diagram. This multiplier, when it's in that position, you on the M, you're looking at the Murray loop mode, but all these others are for Wheatstone. So we'll bring Messrs Hewlett and Packard into the picture. Switch it to 4-wire resistance. So all in the 0 position, 0.02 ohms. 1 ohm goes to 1 ohm. 2, 3, 4, through to 10 ohms. Looking pretty good, except there's a little bit of offset. 10 ohms. 20, 30, 40, through to 100. 100 ohms. 200, 300, 400, through to 1k. That's pretty good, isn't it? And 1k. And here's a bit out. It's a little bit out on the K's. Infinite, well, yeah, a lot of megs. 10k, 10k and 10 or 20 ohms. And we should be able to go all the way through to 1110 ohms, and we're about 10-20 ohms too high. It's a bit dicky on the that range, but that's pretty good. Alright, might try actually using it as a bridge with an unknown resistance. Let's try that. Right, here's the schematic drawn a bit more simplified. The galvanometer has a protection switch where it's either shorted out completely so that no current can flow through the galvanometer, or shunted to reduce the current through the galvanometer. So presumably you'd use that as you're approaching the balance point, and then once you're finally getting near it, you'd switch it to open mode there so that the current only runs through the galvanometer, but you don't risk banging it against either end of its full scale. There's a key switch which operates both the battery power into the circuit and connects the galvanometer into the circuit. So you test that, you press that to do your test. The unknown resistance is connected there, and then we have the 4 decades switches in series, which gives us a range from 0 to 11.11k. The unknown, the other half of the bridge, or the bottom 2 arms, is on the multiplier dial, which has a bunch of resistors of unspecified value. There's a few others of unspecified value as well, but presumably they're at least matched so that these 2 are the same, the next 2 are the same, and the next 2 are the same. So in the middle, have I got an extra resistor there? Maybe I've got an extra resistor. But in the middle, they're presumably equal, or maybe that resistor and this resistor are the same. Yep. So you can never actually go to 0. And they're chosen, I guess, so that it unbalances it just so that you get these ratios. I haven't tried to analyse what sort of values you'd have to have in there to do that. But does that mean you can go up to 1,000 times 11k measurement over a meg, maybe. Yeah, so there's the circuit. So I've bodged on a 6-volt battery and joined that strap across to there for the internal 6 volts, which is where this is connected. And the voltage is getting up here. There's 6 volts between these two terminals, but I cannot get the galvanometer to budge in any position. So maybe the galvanometer is busted, or just a bad connection inside somewhere, maybe a broken wire, maybe these don't do the right thing. No, they connect to here, so can't be that. Yeah, can't be bothered tracing that out for now. Maybe one day I'll try and have a look inside there and see if there is something wrong with the galvanometer. But for now, that will do. I hope you enjoyed that. Disappointing as it was towards the end. If you did, give it a like and maybe subscribe. Catch you later.